Hello students, welcome to the lecture on integrity constraints, and after this lecture we will be able to learn the following objectives. Understand the concept of integrity constraints, discuss about multiple constraints, describe the entity integrity, explain update operations on relations, and explain domain constraints. Let us start with accessing database. We know that unauthorized users can access the database. They can damage data in the database. Also, they can make the database inconsistent. Also, a normal DBMS user can make the database in an inconsistent state because of accident. So, some restrictions should be made in the database so that the users do not make changes to data accidentally. Integrity constraints are intended for the normal user. These integrity constraints ensure that changes made to the database by authorized users do not result in a loss of data consistency. Integrity constraints. Integrity constraints provide a way of ensuring that changes made to the database by authorized users do not result in a loss of data consistency. Stipulation that certain attributes form a candidate key for the entity set. Mapping cardinalities L1, L, many and many. We know that an attribute has a set of possible values associated with it. For example, in the student table, student ID, name, marks. We know that the set of possible values for the attribute student ID is in the range of integers. For attribute name, the set of possible values are a group of characters. For attribute marks, the set of possible values are integers. So these integer, character, data, etc. are called standard domain types. A set of attributes should be unique in a table. A primary key is a column or combination of columns that has the same properties as a unique constraint. Because the primary key is used to identify a row in a table, it must be unique and must have the not null attribute. A table cannot have more than one primary key, but it can have multiple unique keys. Primary keys are optional and can be defined when a table is created or altered. They are also beneficial because they order the data when data is exported or reorganized. Also known as referential constraints or referential integrity constraints, enable us to define required relationships between and within tables. For example, a typical foreign key constraint might state that every employee in the employee table must be a member of an existing department as defined in the department table. The database manager handles these types of situations by enforcing a set of rules that are associated with each referential constraint. An insert operation could attempt to add a row of data to a child table that has a value in its foreign key columns that does not match a value in the corresponding parent table's parent key. An update operation could attempt to change the value in a child table's foreign key columns to a value that has no matching value in the corresponding parent table's parent key. A delete operation could attempt to remove a record from a parent table that has a matching value in a child table's foreign key columns. Entity integrity ensures that there are no duplicate records within the table and that the field that identifies each record within the table is unique and never null. Entity integrity specifies that the primary keys on every instance of an entity must be kept, must be unique, and must have values other than null. The primary key for a row is unique. It does not match the primary key of any other row in the table. The primary key is not null No component of the primary key may be set to null. An attribute can have more than one constraint defined for it. Any data inserted into the table must satisfy all the constraints defined for an attribute. Update operations on relations. The original relational database is considered the view on the migrated OODB. Update operations submitted against the original relational database should be translated into equivalent operations on the OODB. Insert, update, searched, delete, searched. Translating a relational update statement consists of locating the objects to be manipulated, except insert, checking the integrity constraint. Given a relational insert operation which supplies a set of attribute values for a new tuple. Insert into R, column, comma, list, values, value, comma, list. The SQL standard provides positioned delete, which deletes the row pointed to by the current cursor point, or a searched update, which may result in the deletion of several rows. We will focus on the deletion of a single tuple, which takes the form delete from R in bracket R, where k is equal to a, where k is the primary key of R and a is a valid value in k's domain. We consider an update operation which sets attribute p of the tuple t identified by the primary key value as the new value VAL. Update R, set P is equal to VAL, where K is equal to A, where R is equal to K union F union A. If P epsilon A, then setting P to A new value won't violate primary key and foreign key constraints, and on the OO side involves only locating and setting the piece of data to the new value. If P epsilon K or P epsilon F, setting up a new value, must first check against the primary key and foreign key constraints and may change the relationship between objects or even cause object migration. Assertions. An assertion is a predicate expressing a condition we wish the database to always satisfy. Domain constraints, functional dependency, and referential integrity are special forms of assertion where a constraint cannot be expressed in these forms. Ensuring the sum of loan amounts for each branch is less than the sum of all account balances at the branch. Ensuring every loan customer keeps a minimum of $1,000 in an account. When an assertion is created, the system tests it for validity. If the assertion is valid, any further modification to the database is allowed only if it does not cause that assertion to be violated. This testing may result in significant overhead if the assertions are complex. Because of this, assert should be used with great care. Some system developer omits support for general assertions or provides specialized form of assertions that are easier to test. Triggers. Several existing systems have their own non-standard trigger features. A trigger is a statement that is automatically executed by the system as a side effect of a modification to the database. We need to specify the conditions under which the trigger is executed, specify the actions to be taken by the trigger. A trigger can be invoked before or after the triggering event. The triggering event specifies before, after which operations on the table the trigger is executed. A single event is an insert, an update, or a delete, events which can be combined using the logical connective. If a trigger is used to maintain an integrity constraint, the triggering events typically correspond to the operations that can violate the integrity constraint. in a trigger when clause can only be used in combination with A for each row trigger. The clause is used to further restrict when the trigger is executed. For the specification of the condition in the when clause, the same restrictions as for the check clause hold: altering, disabling, and enabling constraints. A constraint may be disabled at the time the table is created and then explicitly activated by the owner at a later time. This is useful for recursive relationships where a foreign key refers to the primary key of its own relation. Loading data would be impossible if the foreign key could not be switched off initially and then switched on after the table has been populated. It is important that data adhere to a predefined set of rules as determined by the database administrator or application developer. Enforcing business rules in the code of a database application. Using stored procedures to completely control access to data. Enforcing business rules with triggered stored database procedures. Declarative ease. When we define or alter a table, no additional programming is required. The SQL statements are easy to write and eliminate programming errors. Oracle controls their functionality. For these reasons, declarative integrity constraints are preferable to application code and database triggers. The declarative approach is also better than using stored procedures because the stored procedure solution to data integrity controls data access, but integrity constraints do not eliminate the flexibility of ad hoc data access. Integrity constraints are defined for tables, not an application, and are stored in the data dictionary. Any data entered by any application must adhere to the same integrity constraints associated with the table. By moving business rules from application code to centralized integrity constraints, the tables of a database are guaranteed to contain valid data no matter which database application manipulates the information. Stored procedures cannot provide the same advantage of centralized rules stored with a table. Database triggers can provide this benefit, but the complexity of implementation is far greater than the declarative approach used for integrity constraints. If a business rule enforced by an integrity constraint changes, then the administrator need only change that integrity constraint and all applications automatically adhere to the modified constraint. In contrast, if the business rules were enforced by the code of each database application, developers would have to modify all application source code and recompile, debug, and test the modified applications. Oracle stores specific information about each integrity constraint in the data dictionary. We can design database applications to use this information to provide immediate user feedback about integrity constraint violations even before Oracle executes and checks the SQL statement. The semantics of integrity constraint declarations are clearly defined and performance optimizations are implemented for each specific declarative rule. The Oracle Query Optimizer can use declarations to learn more about data to improve overall query performance. Also, taking integrity rules out of application code and database triggers guarantees that checks are only made when necessary. We can disable integrity constraints temporarily so that large amounts of data can be loaded without the overhead of constraint checking. When the data load is complete, we can easily enable the integrity constraints and we can automatically report any new rows that violate integrity constraints to a separate exceptions table. Summary. Now in the end, let us summarize what we have learnt in this lecture. The purpose of a referential constraint is to guarantee that table relationships are maintained, and that data entry rules. Referential integrity is the state of a database in which all values of all foreign keys are valid. You can use primary key and foreign key constraints to define relationships between tables. The update rule of a referential constraint is specified when the referential constraint is defined. The choices are no action and restrict. The update rule applies when a row of the parent or a row of the dependent table is updated. The nullable columns of the foreign keys of any rows that are their dependents in a relationship with a delete rule of set null are set to the null value.